Every day, SpaceX pulls one of its own satellites out of orbit and burns it to ash. On purpose. A Starlink satellite is built to last about 5 years. Then it is dragged down and burned away on the way through the atmosphere. Completely. That is the rule, and it works. Which is the only reason a 2.5-kilogram chunk of one should not exist. It is sitting in a wheat field in Saskatchewan. And the part that did burn turns out to be the bigger problem. For most of the space age, a satellite was built to last 15 years, sometimes 20. Starlink broke that idea on purpose. Each one is built to work for about 5 years, and then to be thrown away, not repaired, not refueled, replaced. The orbit was chosen to guarantee it. Starlink flies low, around 550 kilometers up. Low enough that the thin air drags a dead satellite back down within about 5 years, even if nothing on board still answers. Higher up, a corpse can circle for centuries. Down low, the sky cleans itself. That was the entire point. The fear behind it has a name: Kessler syndrome. The moment one collision makes more debris, which causes more collisions, until a whole shell of orbit becomes unusable. To stop that, the deadlines got shorter. In September of 2022, the American regulator cut the time allowed to clear a dead satellite from 25 years down to 5. Everything in low orbit now has to come down fast. And coming down means burning up. SpaceX has a name for designing the satellite to do that cleanly. Design for demise. In its own words, the goal is that a satellite will fully break up and burn up during atmospheric reentry. Fully. Except that word is rounded. The company's own estimate is that about 5% of each satellite survives the fall, most of it silicon from the solar panels. The design is for whatever remains to be too small to hurt anyone. So the satellite became a consumable, a piece of consumer electronics the size of a table, moving at 27,000 kilometers an hour, built to expire. And like all consumer electronics, the moment it expires, another has to take its place. That is the part that compounds. Keeping the current fleet alive already means replacing roughly 2,000 satellites a year, about 5 a day, just to stand still. Each replacement is also a future fire. So a few satellites burn up every day. Here is what one speck leaves behind. A single satellite of about 250 kilograms produces roughly 30 kilograms of aluminum oxide dust as it burns. One object goes up. A small cloud of metal stays. 6 years ago, the satellites burning up left around 2 tons of that dust a year. By 2022, it was 17. The models of the full, planned fleets put it past 360. The dust does not fall back down with the satellite. It stays in the upper air, and it has started showing up where nobody put it. In 2023, a NASA aircraft flew into the stratosphere over Alaska with a mass spectrometer in its nose and sampled 500,000 separate particles. About 1 in 10 carried aluminum and metals that do not belong there. Metals from burned-up spacecraft. 1 in 10. Already, 1 in 10 sounds survivable. Then set it against nature. The planet is dusted constantly by meteoroids burning up. Cosmic dust, the natural background of the sky. Burning spacecraft now put about 10 times more aluminum into the upper atmosphere than every meteoroid in the solar system combined. 20 tons a year from the entire cosmos, 210 from burning spacecraft. The sky stopped being mostly natural. And that is the floor, not the ceiling. The same survey expects that share to reach 1 particle in 2. Half the sky's dust, put there by spacecraft. And the dust came with a signature. 2 of the metals were niobium and hafnium in an exact ratio. The ratio of an alloy called C103, used in rocket nozzles. The stratosphere is now carrying the serial number of aerospace hardware, 19 kilometers up. But the amount is not even the part that is hardest to explain away. Aluminum oxide does not just sit there, it is a catalyst. On its surface, it speeds up the reaction that strips ozone apart. And a catalyst is never used up by the reaction it drives. One particle keeps destroying ozone, molecule after molecule, for as long as it stays in the sky. The pollution does not decay with the satellite, it compounds, and it is slow. A particle forms about 86 kilometers up and can take 30 years to drift down to the layer where ozone actually lives. A satellite retired today is a chemistry experiment that arrives in the 2050s. By around 2040, one projection reaches 10,000 tons of this oxide a year, about 150 space shuttles vaporizing in the air every year. And the ozone layer was the one wound the world had actually started to close. On track to heal by around 2066, the obvious conclusion is that someone is breaking the rules, right? But no one is. The rules are being followed exactly. Burning a satellite to ash is not the loophole, it is the law. The same regulator that worried about collisions is the one that shortened the deadline and forced everything to come down and burn. Every debris rule on the books is satisfied the moment a satellite fully demises. And not one of those rules says anything about what the ash does to the air. Orbital debris has agencies, treaties, standards, deadlines. Reentry emissions have none. The same American regulator that licenses these launches has exempted itself from environmental review of them since 1986, years before a megaconstellation existed. A federal court agreed the launches have no significant effect on the human environment. So the metal goes up unmeasured, by permission. And the reason it keeps going up is simpler than the chemistry. The 5-year life is the business. Replacing the fleet is not a flaw in the model. It is the model. Around $8 billion a year, indefinitely, to keep the sky full. More satellites mean more coverage, mean more revenue. The exhaust costs nothing because no one charges for it. Counting every mega-constellation now planned, American, Chinese, European. The figure is around 74,000 satellites, all of them low, all of them on a 5-year clock, all of them built to come down the same way. One researcher who studies the re-entries put it plainly. The cleanest way to clear orbit turned out to be the most harmful one for the atmosphere. The orbit, the ground, the upper air, each was treated as a place to put what the last one could not keep. The atmosphere is the only one of the three that no agency governs. There is one detail that should settle the argument. The only piece of a Starlink ever found on the ground, that lid in the Saskatchewan field, had been predicted to burn up completely by 2 separate government models. Both were wrong. The promise that it all disappears rests on the same kind of model that already failed in a wheat field. A piece of one is sitting in that field, the rest of it is in the sky, and it is not coming down. So where does a satellite go? When it is built to disappear and doesn't?